This is a tutorial on solving quadratics by factoring. Usually when we factor, factoring is a lot like doing the FOIL method in reverse. So if I have a quadratic equation that looks like y is equal to x squared plus bx plus c, notice that my coefficient term on my quadratic here is a 1. So if that's a 1, it's pretty easy to factor or do our FOIL in reverse. Remember, if we have an x squared plus bx plus c, we get that from our two binomials where we have x, and then we have two numbers, and we're going to call those p and q. So when we were to FOIL this, we would take our first terms and multiply them together. Then we would take our outside terms and multiply them together. Then we would take our inside terms and multiply them together. Then lastly, we would take our last terms and multiply them together. So when we do that, we end up with our b term then being equal to p plus q, and then our constant term c being equal to p times q. So when we factor this quadratic, we're looking for two numbers that multiply together to get c and add together to get b. So let's try this. Here we have y is equal to x squared minus 4 plus 4. And again, we have a 1 here on our quadratic term, so that makes this factoring a lot easier. So again, when we factor it, we're going to get two terms in parentheses that'll look something like this, with our variable x and x. And then we'll have numbers p and q. And the idea is to get two numbers that add together to get our b term and multiply together to get our c term. So we need two numbers that multiply together to get 4 and add together to get negative 4. So the first step here is to think, what combination of numbers, when multiplied together, will give us a positive 4? Well, we can multiply 1 and 4 together to get a positive 4. We can also multiply together a negative 1 and a negative 4 to get a positive 4. We can multiply 2 and 2 together to get a positive 4, or a negative 2 and a negative 2 to get a positive 4. So those are all the integers that we can use to get a positive 4. So now we have to find a pair of these that when we add them together, we get a negative 4. Well, there's only one pair that does that, and it's this negative 2 and negative 2. If I add 1 and 4 together, I get 5, and that's not a negative 4. If I add negative 1 and negative 4 together, I get a negative 5, and that's not 4, or negative 4. 2 and 2 will give us a positive 4, so that's not what we're looking for, because we need a negative. So our only solution then is negative 2 and negative 2. So if it's negative 2 and negative 2, that means one of these is my p, and one of these is my q. So then to write this in factored form, we'll have y is equal to two binomials in parentheses. The first term in each binomial is just x, or 1x, because the only way to get 1x squared is just to multiply x times x. And then the other numbers in these binomials, or in this parenthesis term, would be a minus 2 and then a minus 2 again, because our p here is a negative 2 and our q here is a negative 2. So this is the factored form of y is equal to x squared minus 4 plus 4. Let's try this again. Here we have y is equal to x squared minus 2x minus 15. So when we factor this, we'll have y is equal to some binomial in parentheses, and then another one in parentheses. Notice that we have a 1 here as our coefficient of our quadratic term, so that means we're just going to have an x and an x, because x times x will give us our 1x squared. And then we need two numbers to put in here that will multiply together to get negative 15, multiply together, and then add together to get negative 2. So to do that, we think of all the ways that we can multiply two integers together to get a negative 15? Well, we can get negative 15 by multiplying negative 1 and positive 15. We can also get it by getting 1 and negative 15. We can also get negative 15 by multiplying 3 and negative 5, and then negative 3 and positive 5. Now those are the only ways that we can use integers and get a negative 15. So now we have to figure out if any of these will add together to give us our negative 2. And the only ones that do is this 3 and negative 5. Again, if I add a negative 1 and a positive 15, I'll get 14. If I add a negative 15 and a positive 1, I'll get a negative 14. Negative 5 and 3 gives us a negative 2. And then 5 and negative 3 gives us a positive 2. But we need a negative 2. So it's this combination of numbers right here. So now that we found those, it's a positive 3 and negative 5. We just put in a plus 3 and a minus 5. So this is our factored form of y is equal to x squared minus 2x minus 15. Now what if we were given a quadratic that didn't have a 1 on the quadratic term? So we have this a here instead of just a 1. So this is some number. So if we have y is equal to ax squared plus bx plus c, there's two ways to factor this, or two main ways to factor this. And the first one we're going to talk about is the greatest common factor. A greatest common factor is a number or a variable, basically a monomial, that you can take out of every one of these terms. Well, I can take a 4 out of this term, or I can divide this by 4 if I want to. And I can also divide this negative 16 by 4 and this positive 16 by 4. 4 is a factor of all of these terms. So if I take out a 4, I'll get y is equal to 4 times x squared minus 4x plus 4. And again, I got this just by dividing 4 from every one of these terms. Well, now here I have an x squared minus 4x plus 4. This is just like the quadratics that we were just earlier factoring. So we can continue to factor those. We just need to find out all the numbers that will multiply together to get a positive 4 and add together to get a negative 4. Well, we can get a positive 4 from a 1 and 4, a negative 1 and a negative 4, 2 and 2, and then a negative 2 and a negative 2. So do any of these pairs of numbers add together to get a negative 4? And the answer is yes. It's this last set right here. If we have a negative 2 and a negative 2, that will multiply together to get us 4 and add together to get us negative 4. So if we factor that, we have an x squared, so that's just x times x. And we have a minus 2 and a minus 2, so this is minus 2 and minus 2. And then don't forget about the 4, that was our greatest common factor. We took that out before, so it goes on the outside here. So we get y is equal to 4 times x minus 2 times x minus 2. Now we can have a greatest common factor that's a variable. It doesn't have to be just a number. If we have y is equal to 2x squared plus 3x, I can divide both of these terms by x. So if I do that, I'll get y is equal to x times 2x plus 3. Because both of these are divided by x. So my greatest common factor then is x, and we've just factored this quadratic. But what if there wasn't a greatest common factor? What if we had y is equal to ax squared plus bx plus c, and there was no one number that we could take out of all of these terms? Well, then we go back to our foiling in reverse, or reverse foiling method, where we have two binomials in parentheses that when we multiply them together, we'll get an ax squared plus bx plus c. And remember to do this, foiling, we take our first terms and we multiply them together, our outside terms and multiply them together, our inside terms and multiply them together, and then our last terms and multiply them together. So what that ends up being then is we have an m times n that get us our a term, and a p times q, just like before, give us our c term. But the b term gets a little bit more complicated. It's m times q plus n times p. If I were to FOIL out this expression right here, and I did my first terms, I'd have mx times nx. Well, mx times nx is an mn x squared. Then I do my outside terms. I have an mx plus q, or mx times a positive q. So that would be an mqx. Then if I do my inside terms, it's p times nx, or pnx, and then p times q would be our constant term. And if I add these like terms together, because remember, m, q, p, and n are all just numbers. So my variables are x. So if I take this and I factor out my x, I'll have x times mq plus pn, which is what we have right here.